Okay. I hope everybody can see my screen. So let me just talk about what we covered last time. Last time was our first session in the series, as Yogesh mentioned, and we covered some basic data types, integers, floats, and booleans. And after that, we spoke about conditional statements, the if-else statements. Then we covered loops, the while loops and for loops, which are used in Python. And after that, we spoke about lists, dictionaries, and tuples sets, the advanced data types, we could say. Now, with all of that knowledge that we have gained, we will build on that and learn a few more things of Python. So today, we are going to cover functions. So we'll begin with functions and some sophisticated types of functions which are called lambda functions. They're also called as anonymous functions. Then we'll move on to recursions. We'll touch upon regular expressions, the way we would write the regular expressions to find a pattern of text in a larger text. This comes in handy while looking for a specific kind of data in a very large data set. Once we are done with that, we will think about exception handling, and we'll see how we could handle the exception conditions or error conditions gracefully. And then, if time permits, we'll move on to file handling. So with this, maybe we could get started. So basically functions, I guess many people of you are aware of other programming languages like C or maybe Java. The way we write functions over there is a bit different than how we would write in Python. But the basic concept is same, that a function is used to organize the code. Basically, the code blocks which are to be reused, they are that code block is pulled out and created a function out of it, which we can call whenever we require to execute that part of code. So that also makes the code modular and hence readable. And with this, it also reduces redundancy in the code. So you don't have to write the same piece of code at numerous other places. You can just write it at one place and call it with your arguments, with your parameters, with the values that you want to execute on, whenever you wish to do that. Now, the way we would write a function in Python, it begins with this def keyword. If you see this out here in this center code snippet, def. So that is how we define a function. So we write this def keyword followed by the name of the function and then the parameters that it would take. Parameters are nothing but the values that it would accept so that it can perform some operations on that value. Um, I've written arguments and parameters over here. People use these two terminologies synonymously, but there's a subtle difference, and we'll understand that difference in the next slide. And then we would also talk about, and then it has this return keyword out here, which will allow you to return the computed value from the function into the calling function. So basically, the way a function is structured in other programming languages, it is structured in a similar fashion. The syntax is a bit different. So here, this is the definition of the function. Here I'm calculating square of some number, and that number is passed from a calling statement over here. How to call a function? You just use the name of the function and pass it the values that it requires. You could pass values if the function requires, or if it doesn't require, you could just call it without any parameters or arguments. And whatever value is returned from the function, I'm catching that value over here in this variable, which is I square value. And then we can use this I square value in our function, in our program. Here, I'm just printing out the value. So this is how a basic function is written in Python. Now, there are two types of functions in Python. So the built-in ones, we've seen some of them last time also. This print is also a built-in function. Type, which finds the data type of some variable, is also a function. And here, if you see this ID, this is also a function which gives a unique identifier of this object. Normally, it is a memory location. So there are lots of built-in functions in Python, and whatever libraries Python Python has all of them. We could use functions from all of those libraries. Now, we could also have user-defined functions. And the example that we saw in the last slide, that is a user-defined function. So here again, I'm creating, I have a for loop over here in which I want to find a square of all numbers between 0 to 15. So each time I call this function square and pass that value of I to that function so that it returns me a square of that value each time. So this the number of times it gets called, it depends on how much or what is the range that we've specified in this for loop out here. So this is about the user defined functions. Now let's try to understand the return values. What type of values or what kind of values get returned from Python functions? So you could return just one single value, or you could return multiple values. In other languages, I guess in C, you could return just one value at a time. But here, it allows you to return multiple values also. So let's look at the single return value. So I have a function out here which calculates sum of some numbers, and that sum is returned. And it is caught over here in this IRES variable, if you can see on the left snippet here. Now I'm printing the result of this, printing the sum of these two numbers, which comes to 5 because my numbers are 2 and 3. And uh, Python is a dynamically typed language. So you do not have to specify the type of that data type of that variable upfront. Uh, Python calculates or computes that data type by itself at runtime. That is the same thing that happens for return values also. So you do not specify the return type or the return data type of a value that is being returned. That is why you do not see any data type out here between this def and calc sum. So here this IRES variable, the data type of this variable is also computed at runtime. And if you see the result here at the bottom, it is class int, meaning that the value that is returned is of the type integer. So the type is computed at runtime. This is what we need to remember here. Now, what about multiple return values then? In case of multiple return values, the way you return them, you separate them by a comma. So you see here, this function calculates two things. One is it calculates the sum, and then it also calculates the product of the two numbers which are passed to it. Now I need to return both of these values. So I separate them by a comma and I return both of them. But then what happens here in the main function is interesting. So here in this IRES is no longer an integer or a float, but it is a tuple because there are two values which are returned and you need to have a data type which holds multiple values. And tuple becomes the best choice for holding these two values because one reason is that whatever values you return, they'll always be the same number of values. They cannot be more or less. That is hard coded in the definition itself, right? So tuple becomes the best choice. The other thing is tuples are memory efficient than lists or any other lists or dictionaries, right? That is why a tuple is a preferred choice for holding multiple return values from a function. So if you see here, this is the output of this function, this code snippet on the right hand side. The result is 5 and 6. 5 is the sum and 6 is the product. And both of them are bundled into a tuple. And this bundling into a tuple happens at runtime. It is an implicit action that is performed. And to verify that, we also print out the type of this variable, returned variable, and that, as you can see here, is a tuple. So basically, when you want to return multiple values from a function, you would have to remember that it comes back as a tuple. You could work on that tuple with all the functions that are inbuilt for a tuple. You could this and then work on those values as you please. So the thing to remember here is that multiple return values are bundled into a tuple. Then we spoke about these parameters and arguments, right? There are people use these parameters and arguments terminologies synonymously, interchangeably many times. But there is a subtle difference. So when you have this function which accepts some values in its definition, it is referred to as a parameter. And while you are calling this function and passing some values to that function, those are the arguments. So just wanted to call this out. It is a very simple thing to note and to remember when we are talking about parameters and when we are talking about arguments. The next thing I want to talk about is the scope of the variables. So there are these local variables. So local variables are within a code block and they are not available outside of the code block. So so here, if you see this NUM is a local variable and the scope of this NUM is within this code block of this function. Similarly for squared, this is a local variable to this function. But here, you see you have this string S. It is initialized to some string out here. And there is this function variable scope. So if I call this variable scope function and I try to access this S inside this variable scope, it wouldn't be accessible, isn't it? But to access it, if we can use this global keyword, then we would be able to access it and perform actions on that value. So here, I am just concatenating this string, the outside string, with something else now. So now if I print out the result, the value of S has now changed to outside function plus inside function rather than just outside function, which was the value earlier. So to access the values which are outside a code block, global is the keyword that you would use. That would make these values accessible, or you will be able to modify these values inside a variable scope. So if you want to just access the values, if you also want to modify the values, at that time you would use this global keyword. The next thing is um, uh, how do parameters or how do values get passed from a function when they are from an outside function into the function. There are two ways by which this normally happens. One way is call by reference, in which a function gets a reference to the argument, meaning that if you are passing some integer value, the integer value is stored at some location, and a new variable is created which has a reference to that memory location, we could say, or reference to that variable. Um, that is this call by reference way. And the next way is call by value. So this value gets assigned to another variable, and hence it is a call by value, and there is no reference out there. It is a new variable that gets created altogether. That means that outside of the function scope, the variable will have a different value, and inside of the function, the variable will have a different value. Now, this is what happens normally. But what happens in Python? It is actually a combination of both of these, and it is referred to as call by object reference. Here, the reference to that object is passed. So it is a combination, as I said, for call by reference and call by value, and we will understand in a minute how this actually happens. So I quickly move on to my notebook, and I'll show you a working version of all of these. We'll start with defining, calling, and returning values. We spoke about single and multiple return values. We'll demonstrate that. And then we'll understand this call by object also. Okay, so this is the function definition that we spoke about. This is my function. This is the parameter that we are passing to the function. And this is from where we are calling it. Here, I'm passing a list. And inside, what I'm trying to do is I'm appending a new item to this list. And I'm returning this new list so that I could print it out in the console. So if I run this now, you see this is the output. Each value is multiplied by 2, and a new list is created altogether. So here I wanted to talk about how a function is defined. This is the keyword. This is the name of the function. These are the parameters. This is how you call a function. And these are the arguments to the function. To return the value, return is the keyword. This is just another example of the simple calling and defining a function. Now, we spoke about arguments which are uh, call by reference, call by objects. So here we are talking about immutable values. So immutable arguments meaning integers, floats, tuples, all of these are immutable ones. And here, this is my function and it takes an argument. This is where I'm calling it from. So when I call this, the value of x is equal to 9. So inside this, if I print out the value, I definitely get that value out here. But along with this, I'm also printing out the memory location out here, the unique identifier of this object x. So here, after I run this, you see, this is my first print statement, wherein this was the unique identifier. After I call this function, this is the print statement that gets executed. And here also, the unique identifier is same as it was before. Okay. But as soon as you change the value of this x, once you try to tamper with this value x, Python will allocate a new object identifier for it. So now this value of x is no longer 9, but it has changed to 42 inside this block of function. And hence, if you see the print statement here, now it has a different location, the different unique identifier. But the value of this x outside of this function is still 9. So if you print this once again, you would see that inside the function, once we changed the value of x, the identifier was different. But once you come outside the function and you access this value x once again, it is referring to the same memory location as it was earlier. So this is one way, this is the way by which the immutable values are handled in Python. And this is the object by reference. Call by reference. So here now, let's look at the mutable values. Mutable values meaning the lists and the dictionaries. So this also looks like call by reference, but it isn't. And let's understand how different this is. Now here I have a list of numbers, and I have this function wherein I'm changing the value or changing this list altogether. Basically, I'm appending a new value into this list. So earlier my list was 1, 2, 3. At the end of this execution of the function, my list will become 1, 2, 3, and 4 because I appended a new value to it. But here, unlike the mutable parameters, the original memory location or the original variable gets changed and then no new variable gets created. So here we saw that as soon as the value of x changed, we got a new unique identifier. But here that is not how it works. So if you look at the output here, this is my original list and this is the unique identifier. Once inside the function, this is the print statement that I am referring to now. This is what is referred to, same unique identifier once again. You change it, change the list numbers, but still the ID is same. And once you come outside of this of this function and try to access the list once again, it is the same memory location. So it behaves a bit differently for mutable arguments and for non-immutable ones. But the idea is that it is a call by object. Okay. So moving on, Now that we are talking about parameters, we saw that there are multiple values that you could pass to a function, and all of them have to be defined here in in these two round brackets so that you can catch those values for the function. But what if you do not know how many values are going to get passed to your function? In that case, Python allows us to use this star args keyword out here. What this star args actually means is that it tells Python interpreter that there are variable number of arguments and you do not know how many arguments will get passed to this function. So basically, catch all of those arguments and collect them into a tuple. Star indicates to the Python interpreter that all these arguments which come by, they have to be collected into a tuple. And this is reserved only for positional arguments. So here in this example, you see, you have the call to this function calculate sum. And there are three arguments which you are passing. And all of these three are caught here in this tuple args. So args basically becomes a tuple. And then you are calculating a sum of all of those elements which are passed and they are returned. So you see here, this is the output. And now you get the addition of all of these numbers. Next time you could call this calc sum with more number of arguments or less number of arguments. The function block will still perform the way it performed earlier. So this is about the special arguments. Star args, when you do not know what kind of or how many values are going to get passed to your function. Now, what if you had some key value pairs that are getting passed? So for that, we have this star star out here. So this is actually Python grammar, which tells the interpreter that whatever values are getting passed to this function are key value pairs. And we have seen that key value pairs are stored in the data type called as a dictionary. So basically, this star star indicates that whatever arguments get passed to this function country data out here, store them in a dictionary. And then after that, you could work on this variable just the way you would work on any other dictionary. So for example, here, I am trying to extract the key and value both from this KWArgs dictionary using this function items. And then I'm printing both of these values one by one. So this happens for each of the call that I have. So here you see, I have this country data in which I have the first key value pair as India and Delhi. So this is what gets printed out, country and its capital. Similarly, for the next call, the country and the capital. This is the print statement that we are referring to here. And we are printing what? Printing the key and the value. First key that it gets is the country and its value is India. So that is what got printed here. The next one is capital and Delhi. That is what we passed and that got printed here and so on. So basically, when you do not know what kind of values you are going to pass or how many values you are going to pass to your function, you would use this star args or star star KW args. Maybe we could see a quick demonstration. So you see here, I have this add numbers function and it accepts some positional arguments. In the first call to this function, I'm passing 3 values. In the next call, I'm passing 4 values. Internally, all of these values are added together and printed out. So with the first function call, 3 values are passed. All of the 3 get collected into a tuple and the tuple is iterated over all of the values and a total or the sum is calculated, which is printed out here in the form of this number 6. Similarly, for this second call, now I have 4 values, so my tuple size is 4. So this for loop iterates for 4 times rather than 3 that it iterated for in the previous call, and it printed out the result. So this is how the star args, that is the positional arguments, variable number of positional arguments are handled in Python. Now, about the KW args. So I have student details function, which accepts keyword arguments. So I pass some values out here, which are key value pairs. And again, they are extracted, or we can extract them as the way we would do for a dictionary. So here again, I'm using this kwargs items function, extracting the key and value and printing it out. But here we could work with any other dictionary functions that we know about, as this kwargs is actually a dictionary. And you see here, a dictionary is denoted by curly braces, right? Curly braces, name and the percent, these are the keys, and the corresponding values. This is the first call. This is the result of the first call, this one. And this is the result of the second call. Okay. So now we've spoken quite a lot about regular functions, the functions that we would normally use. Let us talk about some more sophisticated kind of functions now, the lambda functions. So basically, lambda functions are anonymous expressions, anonymous functions. Anonymous meaning they do not have a name, but they return some value. They perform some operation on it and they return some value. There is a specific syntax that these lambda functions follow. So lambda is the keyword that we would use. This function would take some arguments because it has to perform some action on these arguments, right? So you have this second part as the arguments. And then the third part is this expression. What kind of action do you want to perform on it? And these arguments and expressions are separated by a colon. So this is that syntax that a lambda function would normally follow. When to use these lambda functions? When you would want to create some small or one-time use kind of functions, then you would prefer these lambda functions. But remember that these functions or these expressions that we have here, the operations that these lambda functions perform, that these operations have to be very simplistic. You cannot have a very complex kind of an expression out here. And then it could lead to confusion. That is one thing. But then that doesn't serve the purpose then. Lambda functions are for one-time use and for small kind of operations that we perform. They're also used for higher order, used along with higher order functions like maps, filters. We'll see these also in some time in the demo. But basically, try to look at the code snippet here on the right-hand side. So you have this lambda function here, which calculates sum of some numbers. So you have this lambda keyword. These are the arguments. As we saw in the syntax over here, these are the arguments. And these arguments are separated from the expression by the colon. What is the expression? We want to add all of these numbers. So we just add these numbers one by one, and we return a value, which is a sum of all of these numbers. So we could have also written a regular function for this. Then we could have had we could have had this expression inside that function. But instead, we just wrote this anonymous function, something like an inline function. Imagine this like an inline function in Java, and it returns a value. So here, we said that it is also used along with the higher order function like maps and maps, filters, or reduce. Maybe we'll take a look at how this actually works. So you see this, I have a simple function out here, which is a function which adds two numbers. So you have this function which takes two parameters, and this is the call to the function. And inside this, I'm just adding these two numbers together and returning the result. But I could have simply written something like this in one line. So this function does not have a name actually. Hence, it is a lambda function or an anonymous function. I have this lambda keyword. These are its arguments, and this is the expression or the action that we want to perform on these arguments. And how do you work with it? This is the result. So this is actually a this is actually the function reference. This so if we try to print the type of this add out here, that is of the type class function. This is a function object that gets created out here, and we are referring to the function object which is used to refer to this lambda function over here. So this is how you would create a lambda function, and then how to use it for bit more complex things. So you have this higher order function. I have a map function out here. What this map function does is that it takes two parameters. The first parameter is a function, and second parameter is the iterable. So what is a higher order function? It is basically a function which takes an argument as a function. So here this lambda function becomes the first argument, which is actually the function that we are referring to. And here you have the iterable, which is the list. So this map function will iterate over each element of this list and apply this lambda function on each of the element and return a result. So here what we are doing is we are calculating a square of all elements that we have in this original list. And you have a list output over here, which is actually a square of all elements of the original list. So this is how you would work with a lambda function along with higher order functions. Now let's move on to a different topic, which is recursions. So recursion is just one way of calling a function. So the definition of the function remains same as we have already seen, but it is just that it is a function. There is a function call in the definition of the function, and that function call calls itself. So here, if you see, you have this definition of the function, and this is the call to the function. Here I'm calculating a factorial of some number. So, and inside this, if you see, there is this return statement in which I'm calling the function itself by its with its name. That is, I'm calling itself, but with a different parameter. So I have a different value that is passed to the function now over here. So basically, this becomes the base case. This if statement, this becomes the base case, and this becomes the recursive case. So it cannot call itself indefinitely, right? It has to stop somewhere, and that base case will stop that, or that base case is the condition when this calling itself action will stop. And then now you have this recursive case. So that is where we break down our problem into smaller problems, and each time we call the function with a new value. So now maybe we'll quickly go back to our notebook and see an example over there so that things become a bit more clear. So we'll use the same example once again. We'll calculate the factorial of some number. That number is 5 here, as I'm passing that number here. Now, in the first, when this factorial gets called, the value of n is 5. And since n is not equal to 1, which is the base case, it will go ahead and call itself, because that is what we have specified here. But now the call will be not with 5, but with 4. And similarly, this will go on until the value becomes equal to 1. Once the value is equal to 1, the function, the control comes out of the function call, and the value of this factorial, which is 120, is printed out. So basically here, two things to remember: the base case and the recursive case. But along with this, the actual execution of this function happens in a different way. So there are two phases in which this execution happens. First is the forward phase, in which this calling happens. And while this calling happens, there is a stack of function calls which gets created. So first function call will be factorial with the parameter 5. Then the second one in the stack would be factorial with the parameter 4, and so on. This stack gets created in the forward phase, and once we reach this base case, the stack unwinding starts, meaning that now you have the stack ready, which is full of function calls one after the other with different values. Now it is time to execute all of these functions one by one, so that first it will get executed with factorial with the parameter 2, the value gets calculated, and that value is multiplied with the previous value. And so on. That happens for all of the function calls which are stacked together. And once we reach the end of it, we come out of this function call altogether. And that is how we get the value of this factorial of 5, which is 120. So I would urge you to go back and maybe write this whole thing in PyCharm and put it in a debug mode and see for yourself how this works. And note while doing that there is this base case and a recursive case. And in the first kind of first execution, which is the forward phase, you would see that it is just about iterating through the recursive calls. And there is a second phase which starts, in which you would see that the actual calculation happens. So this is how recursions are defined. With this, we end the functions. And now let's move on to the next topic, which is exception handling. So while we are writing our code, while we are executing some things, there are um, some uh, events which can happen, which can disrupt the whole programming sequence. So what I mean here is that um, there could be a zero division error. Something gets divided by zero. That throws an exception, right? Uh, that can also result in crashing of the program. But if you want to really understand what caused this crash, then there has to be some way by which you could put some logs, or maybe handle that whole event gracefully and stop the program from termination. You could just put in some log and then continue with the rest of the program also, isn't it? So for that, exception handling is the way by which we can stop the program from terminating at a premature state. And at the same time, we also can provide meaningful error message in the logs, so that at the time of debugging we can understand the real cause of the failure. Now the way to do it is that there is this try block which Python allows you to use. In this try block, we put in that piece of code which can result into an exception. And after that, to handle that exception, if that occurs, then you have this except keyword. If there is a exception that occurs out here, then this piece of code will get executed. This is what this means. Now, if there is no exception, if this piece of code executes seamlessly, then instead of this except, this control would go into this else part. That is optional, and it is okay not to put it, but it is just for some extra information if you want to put some logs or something. And then there is this finally, which is also also an optional block, in which you would um, put in some piece of code which should execute irrespective of this exception or not. So this will run every time. Every time after this code runs, if there's an exception, this piece of code will run, and after that finally would run. If there's no exception, then after this piece of code executes, it will go into this finally and execute that part of code. So basically, you see here, you have a division by zero division error out here. I'm dividing 10 by 0 and it is throwing an exception. So this part of code gets executed, and that is what you see in the output here at the bottom. And you see that after this got executed, there is this finally block which was executed, and that is the output of this finally block. So this is a basic kind of an exception which you would write. And to write or to handle such exceptions, you would use these keywords try, except, and else, and finally are optional ones. There are different ways by which you could write a try except block. So here there is one exception that I have caught, but there could be multiple exceptions that you might have to handle. So you write all of those here one after the other as separate except blocks. This is an example of how to use this else out here, and this is an example of how to use the finally. But apart from these built-in exceptions, it is possible that you might want to create an exception of yourself, a custom exception. So in that case, to call that exception, the custom exception, you would use this raise keyword. So this raise keyword will call the or it would give us an intimation that some event has happened, which some undesirable event has happened, which we should know about. How to do all of this? Let's go back to our notebook and let's see that in the see that working there. So now I'm trying to open a file here. But that file, if that file does not exist, then the program would terminate if I have not handled it properly. But if I put this piece of code in this try and except block, then I would be able to handle this situation or this scenario gracefully. Meaning that I'm trying to open this file here. If this file does not exist, when I try to read that file, an exception is thrown, meaning that this code block gets executed, wherein I put into the log that the file was not there, and that was the problem. And then I have this finally, in which I close this object. So if I run this now, you see, there is no large red scary error message that has come out, but it is handled gracefully and it has intimated that the file wasn't there. So this is about inbuilt exceptions. So this file not found is an inbuilt exception. But what if I have a condition which I need to handle at runtime, and that is not an inbuilt one, that is custom. Then in that case, I would write a custom exception, and to do that, or to call that custom exception, I would use this keyword raise. So basically, I have a function out here which checks for temperature, and the condition out here is that if the temperature goes below 18, then that is an undesirable situation, and we have to throw an error, or we have to intimate people that the temperature is below 18 now. So now I call this function with a value which is less than 18. So basically, this code gets executed. And since I have put this into a try except block, because this condition was raised, because this exception was raised, this block of code gets executed. And then I get the message that there's an alert, the temperature has now gone below 18. So if I run this with say 18 as the temperature, then there's nothing that would happen because this condition was not, or this condition was not satisfied, hence this exception was not raised. But if it is below 18, then that is an alert which everybody should know about. Okay, so this was another topic which I wanted to talk about, exception handling. There are lots of inbuilt exceptions which are available in Python, and the more you look at these exceptions, you will be able to understand which all situations can be handled inbuilt and how to handle custom exceptions also. Okay, now we come to the next topic, which is regular expressions. So basically, when we have a large text or large data set in which we want to extract some small data sets which are actually in a specific pattern, then we would use something called as regular expressions. So a pattern in the sense you have a date in the dd/mm/yy format. That is a pattern. Or if you have IP addresses are a combination of 4 octets. Each octet has numbers between 0 to 255. So this is also a pattern. Or maybe you could have phone numbers or email IDs. All of these are patterns. And if you want to look for these patterns in a large text, then you could make use of regular expressions and scroll through the whole text and extract only that part of the text which matches your pattern. Not only match, you can also manipulate that text and update that text also simultaneously. You could also validate input formats with this. So if you are getting some input from somewhere, so maybe this date format, you want to validate the date format. If the date is not in that format that you are expecting, /dd/mm/yy maybe, then you could do this validation or comparison using regular expressions. How to use these regular expressions? We have an inbuilt module in Python, which is this RE module. RE module allows us to work with different functions, which will allow you to extract patterns or text of a specific pattern from a larger text. How to do that? So there are characters. Now you see here, these are all characters, meta characters as they call it. And you use these to identify a specific pattern. We are going to see how to use these patterns in a while, but just understand that if there is uh, a character that you want to match, then you would use this dot symbol. If you want to match a digit, then it is /t. If you want to match a word, then it is /w, and so on. How to use this? We are going to see that. So let's go back to our notebook. So this is a simple example. This is my text. And there is a secret code. All of these are secret codes, but I want to extract only those ones which are 3-digit long, meaning 123 999 and 321. I want to extract only these three, but 45 and 6789 I want to discard. So for this, RE is the library as I mentioned, and this RE library has this function called find all. This find all will look at all of the contents or all of the words of this text out here, and it will match this pattern. So we said that /d is for a digit, isn't it? Now I said that I want to match exactly 3 digits. So I put in this /d thrice. So that means 3 digits. And then I print the numbers, whatever numbers I get from. So if I run this now, I'll have to refine this a bit more because now it has extracted 678 also. But basically what we are trying to say is that all those which have three numbers will get extracted using this pattern. This is my pattern and this is the text in which I want to look for that pattern. So find all takes 2 parameters. First one is the pattern and second one is the text, and returns all those values or all those words from this text which match this pattern. So now let's look at something a bit more complex. This is not the only way that you could write the patterns. There could be very complex kind of patterns that you might encounter in real life. And for that, Python has given us quite a lot of other ways. Find all is the method that we just saw, which finds all matches. Everything that is there in that text, it will find all of them. But There is another method called search, which will find just the first match anywhere in the text. So it will discard all or it will overlook all of the matches which it finds after the first match. And then there is one more function match, which will match only at the start of the text. And if it does not occur, if it does not encounter the pattern at the start of the text, it will not go and look for anything else in the text. Even if a match is there, match might be there at the later point in that text. And there are quite a lot of other functions also which RE live module gives us. But these are the ones which we would mostly use. Now we saw in the previous slide that there are meta characters. Similarly, we have quantifiers. Quantifiers are nothing but, now we say that I want to match one or more such characters. So we had this /d, and since we had to match three digits, we put in /d, and /d, that is thrice. But what if we had to match 10 or 15? We cannot go and putting /d one after the other, right? So that is why we would use these curly braces and specify a number between them. So if I had to match the number thrice, then I would say /d, and in these curly braces, I would mention 3, meaning that match 3 digits. Similarly, we have something called as an anchor. So if we want to say that look for the words which start with the character D, or look for the words which end with say W, then we would use these characters or these symbols, caret and dollar. Similarly, there are quite a lot of other ways by which you can create different kinds of patterns which would match the starting and ending of a word, or maybe starting and ending of a piece of text. Or maybe if you want to group something, if you want to group some conditions together, more than one conditions, if you want to bring them together, then you would use these round brackets and square brackets. So let's see some examples of how to create more complex regular expressions for handling more complex patterns. So you see here, this is the same example that we just saw. Match a digit and look for uh, uh, 3 digits over here. So here I have this /d and I have this 3 out here, meaning this is equivalent to having 3/ds. But now this is concise, isn't it? So basically you print out all of these numbers, or you print out or extract all of the numbers here, which are 3-digit long, and that is what you get as the output. Now, let's see a bit more complex example. Let's say I have a text, and from this text, I want to extract phone numbers, which are in this format. So I have this text in which I have quite a lot of phone numbers. Some of these phone numbers are in the valid format, some of them are not. So basically, a phone number is 10-digit long, and it has to be preceded by +91 and dash. That is what the condition is. So my pattern would be /d 10 times, first thing, right? So my phone number has to be 10-digit long. So I say /d and look for 10 digits, followed one after the other. But it has to be preceded by this pattern. And for that, I would write this slash indicates match for this text out here. And this becomes my pattern, complete pattern. And I have this find all method once again, which looks for every valid value in this text which satisfies this pattern. And that is how I get 3 phone numbers which are valid. The rest of them, are not valid. So for example, this one, this is not valid. So it won't figure in the output. This one is also not valid because it doesn't have this dash, which is mandatory in our pattern. So this is how we would create a bit more complex pattern. So let's move on to another example, which will allow us to use some groupings. So we said that if we want to combine multiple conditions together, we would use these round brackets. So that is how we are doing it here. So here what we are doing is we are extracting the user email IDs from this text. So there are two email IDs as you can see here. And if they are valid ones, that is if they satisfy this pattern, then they will come out as the output. So let's understand this pattern now. So every email ID has a username, has a domain, and that is separated by this @character. Correct? So now I have this first group, which says that that is a word, and that word, everything that comes before this has to be grouped together. That is the first group. The second group is everything that comes before this dot. That is what my pattern says. And that becomes the second group. And then there is a third group which follows this dot. So everything that follows this kind of a pattern will be considered. So if I run this now, you see the output here. These are the two values which are extracted. Now let's say I had one more, which does not follow this pattern. And if I run this once again, you see this one gets discarded. And why? Because it does not conform with this pattern, which says that the second group and the third group have to be separated by this dot. Now here this dot is escaped by a slash. Why? Because this dot is also a meta character, but here we don't want to treat it as a meta character. We want to treat it as a character literal, and that is why we escape it by this slash. So now we have created a bit more complex kind of a pattern here. And the more complex the condition is, you could have more such conditions added into your pattern using all the meta characters and anchors and quantifiers that we just saw. So we are going to share this PPT also with you all. So you will get the list of all of those characters and meta characters and how to use them. But there are lots of other online resources also which you can use to validate the pattern that you have created. I'm going to put a link also for that in the presentation, so you will get to see that too. Now all the while we were looking at this function called find all, but we saw that there are multiple other functions also that we could use. Search is one of them. So what this search does is, we said that this search will look for the first occurrence of the match, meaning that I have these two email IDs out here. The moment it finds a match for this pattern, it will stop looking for the pattern in the rest of the text, and it will return only the thing that it has found. So here, this search returns an object, and if I run this now, this is what I get as the output. The first one. The second one is also a valid username, valid email ID, but the search function will not look at this and return only the first match. To extract just the first part of your first group of your regular expression, that is this username, I would use this index. So 1, 2, and 3 give me the values for each group. This is how grouping and this search can work together. Okay. So now we are done with regular expression also. And we still have a lot of time on hand. So maybe we'll quickly move on to file handling also and cover that too. So this is the validator and debugger that I was talking about. Here you could put in your regular expression and see if it is valid or not, and it can also help you correct your regular expression. Okay, now about file handling. So there are different kinds of files that we might have to work with. Data can be stored in different ways, and you will have to handle all of that data or extract that data in different formats. So you could have text files, or you could have XMLs, or you could have some configuration files, which are YAML files, or you could have some database files, which are .db or .sqlite kind of files. But we have there are times when you have to work with all of these files, extract data from these files, and work with that data in your applications. So first we have to remember that all of these files are encoded or stored differently on our in our hard disks. The normal way or the most popular way of storing them, or it is UTF-8. So that is that encoding method by which you convert your text or convert your data into characters or into binary data or into bytes, and you store them on your machines. There are multiple other formats that they can use, but UTF-8 is the most prevalent one. And whatever functions we will see today, they all work on UTF-8 format. So basically, when we are talking about files, any kind of file, we first have to open that file. We have to maybe write to the file or read from the file. And even before doing all of this, we have to check if the file exists or not. And once we are done with all of this, the file handle that we create, file handle is nothing but the object that we create to work with the file. We close that object or we discard that object. So basically, if you look at the code snippet out here, the first line in which you specify the file that you want to work with. And then you also specify what you want to do with the contents that are there in the file. Do you want to write to the file or read from the file? Or if do you want to append some content into the file? That mode is specified as a second parameter to this open function. So you have this file object which gets created, which is a reference to this file. And you also now know what kind of action you want to perform on this file. So basically now here I'm opening it in a write mode. So so this object that I'm going to use, that will be used for writing to a file. So here I write some text into the file, and once I'm done with it, I close it, meaning I discard that object. Now I want to read the file. So to read the file, I open it now in the read mode. Here, since it is a read mode, it means that I cannot write to it. Here it is a write mode, means I cannot read from it. But if you want to do both, then you can combine it. Now, here what I'm doing is I'm opening the file and I'm reading it line by line. I'm iterating over it. But there are different functions which are provided by Python. Read function will allow you to read the file in one go. Read line will allow you to read a file line by line. Here, when I do this file read, everything that is there in this file gets printed out. Now to see if a file actually exists or not. So if it doesn't exist, then that means that whenever you write or read to the file, write to the file or read from a file, there'll be an exception that would get thrown. So to handle that exception gracefully, we first have to see if the file actually exists or not. That is the condition that you would use. And this exists function allows us to do that. And once done, this object that we create, that we discard using this close. But there is another way by which you can open a file, and in that you do not have to close this object, and that is the with keyword. So we'll see that in this demonstration. Let's go back to our notebook. Okay, so I have this file out here. I open it in the write mode. But you see here, I have this with keyword. So this with allows us to work with the code block, which follows after this with, and after you exit from this code block, the handle is discarded. So we do not have to do file.close then any longer. So here what we are doing is we are opening this file in a write mode. This is the object that we get as a result of that. And we use that object to write to the file. We write some text, and then we have another with block, which we would use to read from the file. And what do we get after reading from the file? Whatever we wrote inside, we get that as an output here. So this is and now here we are using just W and R. If we would have used append mode here, each time when we use open a file in this mode of write, that is this W mode, whatever contents there were previously, they get overwritten. But if you do not want to overwrite them or you want to preserve the previous contents, then in that case, you would open this in an append mode. That way, whatever new content you want to write to the file, that gets written at the end of the file. So, and there are different ways by which you can work with these files. As you explore more, you will be able to see the different ways by which you can work with files. Okay, let's go back to our presentation now. A quick recap of whatever we finished. We spoke about regular functions. Then we spoke about anonymous functions or the functions which do not have a name, unnamed functions. Then we spoke about recursions, in which a function calls itself until that base case is attained. Then there are some events, undesirable events that could happen, which could terminate your application. So to stop that from happening, we use this exception handling. And there are user-defined exceptions which we could have, or you could have the inbuilt exceptions which Python provides, and we could leverage those. Then we spoke about regular expressions in which we could write a pattern, and that is the pattern which we would look for in a larger text. And to do all of this, there is this RE module which Python gives us. And using this RE module, we could look for a text in different ways. So you could find all matches, or you could find just one match, or you could find those lines where the pattern, or those lines which start with a specific pattern, that is this match function. And then we spoke about meta characters, quantifiers, anchors, and combining all of these together to form a complex kind of a pattern to look for different kinds of combinations of text in your larger text. And then we also spoke about file handling, how to open a file for writing, reading, or for appending text. And we have to work with files quite a lot of times when data is stored at different locations or in different kinds of formats, and how to work with those. If it is a CSV, then comma separated values, how to extract them. So all of these things, if you want to do, you have to begin by opening a file and getting the contents of the file into your program. So file handling is the first point from where you would start when you want to work with some kind of data. So that's all I have for today. So if you have any questions, maybe we could take those questions right now.